Good morning. Welcome to the video lecture on the topic of electrical terminology. But before we start, let me introduce myself. My name is Johari from MIAT Unit KL, and the video lecture is made for the class Electrical Fundamental 1. And the syllabus is according to MIAT SLT number 3 and also in according to DCAM module 3.3. The syllabus for electrical terminology include the following: potential difference, electromotive force, voltage, current flow, conventional and electron flow, resistance, conductor in charges. The video only cover the potential difference here, the current, and also the resistance, and the rest of the topic are not covered. First topic, potential and potential. To understand potential difference, let us look at the water pressure at these two tanks. One tank is having 100 psi, and second tank is 10 psi. So between these two tanks, there is a potential difference of 90 psi. If we would connect a pipe from 100 to 10 psi tank, then the water will flow from the higher pressure 100 psi to lower pressure 10 psi. The potential difference is 90 psi. Look at these three water pumps. The function of the water pump is to generate higher pressure. So it sucks a lower pressure and produce a higher pressure. Similarly, for electricity, then you instead of pump, you have generator that will build up the potential from the lower to the higher potential. Here you can see the units that's going to increase the potential of the electricity. Here we have the generator, and next we have a battery. The same way we can see if we got two water tanks, one produce 100 psi, the second one produce 10 psi, and each one have their own pressure. What is important is there is difference between the 100 psi tank and also the 10 psi tank. If you were to conduct a pipe, then the water will flow from 100 psi tank to 10 psi tank. This represents the potential difference that is causing the current to flow. Here you can see the pump that is creating the flow of water. Then what the pump does is it produces higher pressure on this side and is taken for the water from low pressure from the intake side. This represents the generator in the electrical system where it will cause the electron to flow. What actually is potential difference? It is the difference in potential between 2 points. And because you have the different potential between 2 points, then it causes the electron to flow from the lower potential to the higher potential. The SI unit for potential difference and also potential is volts, and commonly referred to voltage, which is measured by using voltmeter. When you have potential difference between 2 points, then it creates the EMF, electromotive force. Electromotive force is the force that is going to push the electron to flow, and unit measure is volts. And there are other terms that come about. When you have the voltage, you got the voltage drop, the potential difference, the IR. These are all relating to the what we call electromotive force. The unit of measure of EMF is volts. voltage. And it is also called automotive force or potential difference. Voltage is produced by different units, different materials, such as voltage produced by battery, voltage produced by generator, solar cell, etc. And the letter representing the voltage is V, or sometimes we use E. E for electromotive force, V for voltage. What are the factors that affect the value of EMF? Whether high voltage or low voltage? Then it is called the power source. The generator, some generator produce higher voltage, some generator produce lower voltage. And also the batteries. Some battery low voltage, some battery is higher voltage. Then we look at the second topic, which is the current. The unit of current is amperes. But if the ampere is too large, then we can use smaller unit. For example, milliampere, which is 1,000 of amperes, or 1,000,000 ampere, which is the microamperes. What is current or current flow? It is a measure of rate of flow of current or electron, depending on which convention you use. When you have potential difference in a circuit, then the current will be produced. And current is also defined as number of electron flow per second. This is the rate, because you got time there. And the unit is amperes, represented by the letter I. I mean, the greater the rate flow electron passing through a point, the greater the sink intensity of the current. So 1 ampere of current is a flow of 1 coulomb per second. That means 1 coulomb of electrons flow past a point every second. And what is 1 coulomb? 1 coulomb is the amount of electron equal to 6.24 times 10 to the power of 18 electrons. According to Ohm's law, the value of current is given by V over R. V is the voltage, so the factors affect current are the voltage and the resistance. But what are the resistance affected by? The resistance is affected by 4 items: the material, the diameter, the length of the wire, and also the temperature. For the current flow, there are 2 conventions. We have the conventional current flow and also the electron flow. So these 2 conventions explains how the current flow in a circuit. What is conventional current flow? It come up with, this is the original idea. Conventional current flow original idea when at that time people didn't know that current is caused by flow of electron. They thought that current is caused by positive potential that flow. And of course, naturally, it flow from positive terminal to negative terminal. But now we know that current flow is not the flow of positive terminal, but it is electron flow. And the electron is negative. So the flow of current is from negative terminal to positive terminal. Let's say here you got negative terminal, the electron will flow from negative terminal through whatever path it got taken to the positive terminal. Why do we have 2 conventions of flow? Why do we have current flow and electron flow? Basically, there's a gap of knowledge. Before we know that current actually is full of electrons, the scientists at that time thought that it is the flow of positive particle. Thus, it flows from the positive terminal to negative terminal. And now we know it is not true. It is now, we know current is the flow of electron, which is negative charges. which flow from negative terminal to positive terminal. We got three types of current: direct current, and it's shown by the graph here. You see the current is steady, it's not moving, and as the time passes, the current remains. So what do you say about direct current? The movement of the electron or current is one way, it's not changing. And the amplitude, the amount of current, the value current is steady, it's not changing. And second, we have the pulse setting DC, and here you can see it's a wave, but it only occurs on one side. On the positive side, the example is, that means we know that the electron can flow one direction alone. What makes it different is the rate of flow changes. So you have zero here, and then slowly the rate flow increases until it reaches the peak. And then again, it go back to zero. And again, it go to second part from zero to the peak. So what can we say about the flow of the current? It's flowing one direction, but the magnitude changes from zero to the peak. And the last one is the alternating current. And we can see from the graph, the flow of current is two directions. You have positive flow one side, and then got the negative flow. So for the AC current, actually, the current is pulsating, and one side it go one way positive, and then the next second, the next minute, it will go opposite way. So you can see the electron actually is pulsating left and right. And we look at the effect of the current. What does current do? Current can produce heat. For example, in toaster, rice cooker, and current can produce lights, for example, in lamps. And current can cause movement, for example, in a motor. And it can cause chemical effect. For example, in a battery, when you charge battery, the chemical property of the plate changes. Here you have the heating effect. You got the iron, you got toaster, and you got the rice cooker. And we have the light effect, light bulbs. And we got the chemical effect on the battery and the magnetic effect on the motor. Next, we look at the resistance. What is resistance? You can define it as the property of material that opposes the flow of the electron. And some material provide more resistance to the flow of electron, and another material provide less resistance. And the unit of measure is ohm, symbolized by omega. And the letter to present it is R. The next is conduction. What is conduction? This is not a common term used in electricity, but we know it is reverse of resistance, 1 over R. There's a term that is used opposite to resistance. And the unit is Siemens. It used to be MHO, mole, which is opposite of OHM, ohms. But now they have come up with new unit, which is Siemens. Next, we look at the electrical charges. And the unit is coulombs, the SI unit for coulomb, and it is measured by the current times. The electrical charges is measured by current times 1 coulomb is equal to 6.24 times 10 to the 18 electron. These are charges. And then 1 ampere actually is flow 1 coulomb per second. Therefore, if you take the how many coulombs do you have, then you time the ampere times. That's all for this topic. Thank you very much.